How are you, my friends? This is lecture 36 of the Algebra Course lectures, dividing polynomials. And we have a remainder and factor theorems. So there are four ideas here in the objectives: long division, synthetic division, the remainder theorem, and the factor theorem. Dividing, we have to divide polynomials because if we need to graph polynomial functions, we need to find the zeros. And to find the zeros, we need to factor. And in the factoring process, sometimes we need to divide polynomials. Look at these functions here. This is a cubic. This is power 4, more complicated. This is too much complicated, x to the power 5. We need to factor all these in the coming lectures. Now, just to remind you that this is a review one, if we divide numbers, so easy to remember from high school somewhere, 92 divided by 5. So the 5 here, we call it divisor. The 92, we call it dividend. 9 divided by 5 is 1. 1 times 5 is 5. Then you subtract, you get 4. Bring 2 down. Now 42 divided by 5 is 8. 8 times 5 is 40. You subtract. So 2, we call it the remainder, and the quotient is 18. Now just simple thing here, we can write 92 divided by 5 is equal 18, which is the quotient, plus 2 is the remainder over the divisor. Or if you multiply here by 5, you get 92 is equal to the quotient here is 18 times the 5 is the divisor plus the remainder. So you can write it any way you like. You can write quotient is 18, remainder is 2. I put this example here just to remind you the way we divide, because we are going to divide polynomials in X. That's another example as review 2. Here's the page 2. 6,325 divided by 25, find the quotient and the remainder. I put it here for you, you can read it at your leisure time. This is review number 3. Same way, we divide and then multiply and then subtract. We get the quotient and the remainder. Remainder can be 0 or number. Now, division algorithm. Remember the example we had, 92 is equal 5 times 18 plus 2. 92, we can just replace that by a function p of x, we call it dividend, as we said. 5 is d of x is the divisor. It's a function in x. Times 18 is the q of x, which is the quotient, plus r, which is the remainder. Now, if you divide by d of x, which is the divisor, so we get p of x divided by d of x is equal to the quotient, that's the answer there, plus the remainder over the divisor. You can use this rule here. Let's take example 1. Cubic polynomial function here, 6x cubed minus 19x squared plus 16x minus 4. Let's divide by x minus 2 and then write the answer in this form. This is a very important question. Please pay attention. If you understand example 1 in the long division, I will go slowly here, then you can do all the other questions. Now let's start here. Here, we have to put this in descending power. So the highest power here, 6x cubed. See, how do we start? 6x cubed divided by x. See, this is the highest power here. This is the highest power. So it will be 6x squared. I write it up. And then I multiply by all this. You see, divide, then multiply. 6x squared times x will be 6x cubed. 6x squared times minus 2 minus 12x squared. Then subtract, remember. So I put the whole bracket here, then I subtract. So minus with this will cancel. Minus and minus becomes plus 12x squared. And we have here up minus 19. So minus 7x squared. Then I bring down 16x minus 4. Then I repeat the process. See what I explained here? I just repeat the process. Minus 7x squared, this is the highest, divide by the x, because that's the highest. Minus 7x, so I write it in the quotient there. Then I multiply, remember. Divide, multiply, subtract. Minus 7x times x minus 7x squared plus 14x. Then I subtract the whole expression here. This will cancel. So minus with the plus 14 becomes minus 14, and we have 16x, that's 2x. Then I repeat again, 2x divided by x is plus 2. So I'll multiply back 2x minus 4, then I subtract. So everything will be here 0. So the remainder 0, and that's the quotient there. 6x squared minus 7x plus 2. Now please study this example before you see others. If you understand this, you can do any long division. Let's take another one. 4x cubed minus 3x squared plus 1 is divided by x minus 2. Let's find the quotient and the remainder, then find the addition q plus r. You can try it if you like here. You can try it yourself, and then you can check the answer. So this one here, 4x cubed minus 3x squared plus 1, divide by this. As I mentioned before, the highest power divided by the highest power to be 4x squared. So you multiply again, see? Minus 8x squared. Then you subtract. This will be cancelled. Minus with the minus becomes plus. Minus 3, we see inside here 5x squared plus 1. Again, 5x squared divided by x will be 5x, then multiply back. See here, we cannot add the 1 and the minus 10x. See, because we said here, combine only like terms. Remember that. So we have here minus and minus 10x, and there is a plus 1. I cannot say 11, remember. So 10x plus 1 divide. 10x divided by x will be plus 10. So when you subtract here, you get 21 is the remainder. So remainder 21, the quotient 4x squared plus 5x plus 10. When you add them, it will be 4x squared plus 5x plus 31. Now let's look at example number 3. We have a polynomial of degree 5, 27x power 5 minus 9x power 4 plus 3x squared minus 3 divided by this one, 3x squared minus 3x plus 1. This one is equal to ax cubed plus bx squared plus cx plus d. That means this is the quotient plus ex plus f. That's the remainder over this. Now find the value of a plus b plus c plus d plus e plus f, which is one number. So the whole idea here is to do long division. So please, you can take a minute there, or maybe 2, maybe 3, and then divide long division. I put the answer here for you. I will leave it for you. It looks very nice. I will leave the answer. Please check it here. Divide, go slowly, divide, multiply, and then subtract until you get 3x minus 5. Please read it carefully. So that's the remainder. And then the quotient will be the up here, 9x cubed, 6x squared plus 3x plus 2. Combine only like terms, remember. See, when I say combine only like terms, you cannot combine squared and the cube. So you have to put cube and squared. You combine squared with the squared, cube with the cube. Now, these are the numbers. A is 9, B 6, C 3, D 2, E 3, and F is minus 5. When you add all these numbers, you get 18. Nice question. Now, let's go to synthetic division. Synthetic division is a simple, easy way, very quick to divide polynomials when the divisor has the form x minus c. Let's look at this example directly. 2x cubed minus 5x squared plus 3x minus 10. Let's divide by x minus 3. Now the method here, we use only the coefficients. So I put 2, see the 2 here, coefficient minus 5 and the coefficient 3 and minus 10. Then here I call this a chair. So in the chair I put the value, which is the 0 of this, which is c. See, x minus c is equal to 0, so x will be c. Or x minus 3 is equal to 0, x will be 3. On the chair here, I put the value of c. So what will happen here? I bring the 2 down. See, number goes down. So this 2 will go down. Then I go with this arrow, multiply. See, multiply here. Now this will be 6. Then I add. Minus 5 and 6 becomes 1. Then I repeat the process. 1 times 3, 3. You add 6. 6 times 3, 18. You add 8. The last number is the remainder, easily. And this is the quotient, see, 2x squared. Why x squared? Because we go less by 1. X cubed, the quotient will be squared. If this is x power 5, the quotient will be 4. If this is x power 6, the quotient will be x power 5. So this one, 2x squared plus 1x plus 6, that's the quotient and that's the remainder. Very fast. You can use also long division if you like, but you can use synthetic division only if you divide by x minus c. Now we can have x plus 3 also. So on the chair, we put minus 3. In the synthetic division, remember, the number goes down, then we multiply, then we add. This is a comparison. Same question. This is a long division, and this one is a synthetic division. See, we get the same remainder, minus 4 and minus 4, with the quotient here, 2x squared minus x minus 3, 2x squared minus x minus 3. Same answer if you use any method. This is long. We can say this is little short. We call it synthetic division. In the synthetic division, we only use coefficients. Let's take 2 more examples. This is a function here. You can pause the video if you like and try it. Use synthetic division to divide this by this. So I take the coefficients, 6 minus 19, 16 minus 4. Here on the chair, I put 2. Remember down here in the second example, I put minus 3 on the chair. Remember that we call it chair. Now on the chair here, I put 2. 6 comes down, 12. Minus 7, multiply. See, minus 7 times 2 minus 14. You add 2. And multiply 0, okay? Sometimes you get 0, sometimes you get number. So this 0 directly goes to the remainder, and this is the quotient. I said here, see example 1, because the same question here, exactly the same question we have done in example 1 by using long division. Let's see number 2. Can you try it, please? It's nice to try because there is something strange here. See, this is x power 4, x squared. And this is x power 1. What's happening to the cube? Remember, you have to be careful. In the cube here, I put 0. Every missing term, you have to put a 0. Sometimes 1 missing term, sometimes 2, sometimes 3. Every missing term, you put 0. And then you divide normal. 1 comes down. On the chair, I put minus 3. So when you add here minus 3, multiply minus 3, and minus 3 becomes 9. You continue here until you find the remainder 1. And see the quotient here? See, look at the function. The function is x power 4. So the quotient, 1 degree less, so x cubed. Minus 3, see the coefficients, 3x squared minus x plus 1. That's all the quotient. Now, when dividing this, let's find the quotient and the remainder. And also let's find p of minus 2. I will add one more question here. See, I will divide x cubed minus 6x squared minus 28x minus 2 by x plus 2. I need to find the quotient and the remainder, and also p of minus 2. You know, this is the image, p of minus 2. The function is p, so minus 2, I can replace it in the x. And I will show you also what can you do else. So let's divide here. 5, put the coefficients as usual, minus 6, minus 28, minus 2. 5 comes down, multiply. So minus 16, multiply minus 16 minus 2 is 32. When you add, you get 4. Minus 8, when you add, you get minus 10 is the remainder. Remember, see, the remainder here is minus 10. And what is the quotient? 5x squared minus 16x plus 4. Now, if I say find p of minus 2, remember, we have done this before many times. P of minus 2, 5 times minus 2 cubed minus 6 minus 2 squared. Replace minus 2 in the function. You get minus 10. Is that a coincidence? No. Minus 10 directly, we can get it from the remainder. So if the image is needed, use the remainder from synthetic division. So this is minus 2. If I replace it in the function, directly I will get the remainder, believe it or not. minus 2, again, minus 2, replace it there, you get the remainder. If you change this to 7, replace it there, you get the remainder. If you replace it by 1 or 0, so P of minus 2, that's the image, remember, is equal to R, the remainder, always. And that's what we call it, remainder theorem. That's the theorem here. A polynomial P of x divided by x minus c, then the remainder is equal P of c. Remember here in English, we can say the remainder equals the image of the c. P of c is equal R. So easy, look at this. 3x power 5 plus 5x power 4, etc., etc. Find P of minus 2. I know you can replace minus 2 in the function here, but sometimes the numbers are difficult. So what can you do instead? Just synthetic, normal synthetic, and then take the remainder only is equal to the image. Now in this example 6, we need to find R, the remainder, if this polynomial f of x is equal to x to the power 40, etc., is divided by x plus 1. We notice here that if we use synthetic division, then it will be not practical because we have to put 1 for this x power 40, then we have to put 0 for 39, 0 for 38, 0 for 37. So instead we can use remainder theorem. So what can we see here? Remainder theorem, we says the remainder that we need is P of c. That's the formula, remember that. So this is the function here, f of x, and we have divided by x plus 1, so c will be minus 1. Just replace minus 1 in the function f. So minus 1 to the power 40 plus 12 to the power times minus 1 to the power 9 minus 8 times minus 1 in the x plus 17. Remember here, this is 40 even number, so that's plus 1. And this is an odd number, it's minus 1 times the 12 becomes minus 12. So the remainder is 14. So you can do this in 5 seconds instead of dividing by synthetic. Let's look at another nice question. Given the polynomial function P of x, and there is a k there, you see? There is a k, 15k minus 8 inside the function here. Find the value of k if the image of 2 is 6. Remember, the image of 2 means P of 2. Image of 2 means P of 2 is 6, equals to 6. So we know R equals P of 2. So we just take the function here, put all the coefficients, use synthetic division, 1. See, there is no cube here, so I put 0, remember, missing. Minus 3 for the squared, minus 1 for the coefficient, and all this is constant. So I write 15k minus 8. You see, all this 15k minus 8 in the constant. So the 1 comes down, multiply, 2, add, multiply 4, add, multiply 2, add 1, 2. So 15k minus 8, because minus 8 plus 2 is minus 6. So now this one is P of 2. P of 2 is given, see? It's given 6. So I put 6 equals 15k minus 6. So 12 over 15, and then divide by 3, so k will be 4 over 5. Now the last theorem here, factor theorem, we call it. It's very important, very important. C is a 0 of the function if and only if x minus c is a factor. So c is a 0. See, remember here, the remainder is 0. That means P of c is 0. Then c is a 0. So all these are the same meaning. The remainder is 0. P of c, because P of c is equal to the remainder, then c is a 0. Directly we can say x minus c is a factor. Now remember, if the remainder is not 0, then c is not a 0 of the function. Just here to explain something very important. If 2 is a 0 of a function, then we can take the factor here. X minus 2 is a factor. If we have minus 3i is a 0, complex maybe. So we say x minus the 0. See, it's always x minus the c, the number. x minus, and the 0 itself is minus 3i. So x plus 3i is a factor. Here we have something in the radical, 1 minus square root of 5. So x minus the same 0, then you can change the sign here, becomes x minus 1 plus square root of 5 is a factor. That's very important to understand, please. Now, easy question really here, number 8, we have two parts. Is x minus 1 a factor? See, we have x power 4, x cubed plus 4x minus 6. So you check the remainder here. You divide synthetic by 1, which is the value of c. Check the remainder, the first one. So I put here, remember all the coefficients, 1, 1. See, there's no squared, remember, no squared. So I put 0 for the missing, and then 4 and minus 6. So let's use synthetic division and the factor theorem. So I put 1 here, 1 comes down, etc., until the remainder is 0. So if the remainder is 0, yes, 1 is a 0 of the function. So x minus 1 is a factor, since the remainder is 0. So when you factor this later, then one of them will be x minus 1. Then you have to find the others. Can you try the second one, please? See, this is not easy to factor. 5x power 4 minus 18x squared plus 7x plus 11. But we can answer, is this x plus 2 factor or not a factor? This is example 8b part, solution. I put here two methods. Method number 1 is the old way. You can just replace or substitute the minus 2, which is the value of the c, in the function. And sometimes you have to face a lot of calculations. So you get a number here. So this 5 is the remainder. R is not 0. So that means x plus 2 is not a factor. Or I prefer this method. Use synthetic division. Just put all the coefficients, 5. Remember, there is a missing cube here. So I put 0, minus 18, 7, and 11. 5 comes down, continue the division until you get 5, which is not 0. See, the remainder here is not 0, means x plus 2 is not a factor. Now, this is a nice question, really. We have to find the value of d. If x plus half is a factor of this polynomial, f of x, 10x to the power 4, cubed squared. See here, what's the problem here in this question? This one is not arranged. See, we have 3x plus dx plus 4d. You have to be careful about the coefficients. You can try it yourself, please. Now we say 10x power 4, 9x cubed minus 4x squared. Take a common factor here, x, that's the coefficient of the x, d plus 3. Plus 4d, this is the constant. See, be careful here. See, 4d is the constant. Here we have x. So 3 plus d all times the x. Now remember, we said in the question, x plus half is a factor. That means the c value is minus half. I put it on the chair. Then I make synthetic. And if this is a factor, the remainder for sure should be 0. So be careful here. I put 10, then 9, minus 4, d plus 3, 4d. There is no missing here, right? 4, 3, 2, x power 1, and then constant. Bring the 10 down, multiply by minus half, you get minus 5, add 4 here until you get minus 6, so multiply by minus half, that will be 3, add d plus 6, then multiply by minus half, so minus 3, 6 times minus half, minus d over 2. When you add 4d minus 3 minus d over 2. Right. The remainder is 0. So I take all this remainder here. See, 4d minus 3 minus d over 2 is equal to 0. Then I take 3 on the other side. Here I find LCD, which is 2. So 8d minus d, 7d over 2 is equal to 3. Then d will be 6 over 7. This is an important question. Find the polynomial function because the zeros are given. Find the polynomial function of degree 4. Please study this more than one time to understand the idea. Find the polynomial function of degree 4 that has the zeros 1 minus 1, square root of 2 and minus square root of 2. And constant term 6, that's a condition. We will see it at the end. Now, if I have 4 zeros, 1 minus 1, square root of 2 minus square root of 2, and I know the degree is 4. So how do I start? I say, let P of X function is equal to 4 factors. X minus C1, X minus C2, X minus C3, X minus C4. That's easy because just remember that if we know C is a 0, then X minus C is a factor. That's the important key point here. So I take 1 and replace it here. C1, I replace it second one, no problem here. And then minus 1, it will be there, X plus 1. You can put X minus 1, X plus 1. It's the same. Then X minus square root of 2, X plus square root of 2. So we have 4 zeros, 4 factors, degree 4. Now you need to multiply. Now multiply, please, in a smart way. Remember difference of 2 squares, X plus 1, X minus 1, you multiply together. Then X minus square root of 2, X plus square root of 2 multiply together. So apply this formula twice. Then please continue in the next slide to see the function. We need the whole function. Now, when you multiply, I put here again the same formula so that you can see it. X plus 1, X minus 1 will be X squared minus 1. This one, remember difference of 2 squares. So X squared minus 2. Just multiply by FOIL method. And then completely I added here. So minus 2x squared minus 1x squared plus 2. That's the answer. Remember, there is a condition and the question says, I will show it to you here, and constant term is 6. So the constant term is 6. But what is the constant term here? It is 2. So I have to make it 6 because the question said the constant term equal to 6. So just multiply everything on this function here because of the condition by 3. So 3x power 4 minus 9x squared plus 6. That's the function. If you find the zeros, you will find 4 zeros there. Now, this is a really nice question. I have a polynomial function here of degree 3. So that means we know there are 3 zeros, x cubed, something here. Not easy to factor. See this one? If you try to factor it, not easy. So if I say, I give you one of the zeros, only one, just as a help or hint. If the number 1 is a 0 of this function, find the other zeros, 2 other zeros. It's really, really nice to try this before you see the solution. If 1 is a 0, that means x minus 1 is a factor. And also, you can divide by synthetic. So 1 is a 0 here, and the remainder should be 0. And we know it is 0. So I put here the coefficients, 1 minus 3, 1 and 1. And then divide by 1. That's the 0. 1 is a 0. So 1 comes down, 1 minus 2, add minus 1, multiply. See, we know it is a 0. If we know it is a 0, why we divided? To get the quotient, guys, here. See the quotient here, x squared minus 2x minus 1. We try to factor. See, x minus 1 is a factor here. I put x minus 1, then another quotient. See, x squared minus 2x minus 1. The only way you can get it from the quotient, and a is 1, b minus 2, c is minus 1. I cannot factor. If I can factor, I will factor. But since I cannot factor, I have to go directly to the quadratic formula. When you use the quadratic formula and simplify, these are the other zeros. The other zeros are 1 plus square root of 2, 1 minus square root of 2 with a nice color here. Now, I have prepared some questions for you. Divide this one by x squared minus 4, find the quotient and the remainder. Another question, if all this degree 5 divided by this is equal to 2x cubed, I gave you here the answer, 2x cubed, plus a, x squared plus bx plus, that's all the quotient. And then the remainder is cx plus d. Remember, we did one example similar to this. Then find a times b times c times d, just a product here. Here, find the value of this m if the remainder is 72. When you divide this polynomial function by x minus 4. We need the value of the m. Here just factoring, factor a, factor b, and try to do it. See, this is very similar except we have squared and cube. Please try to be careful. Here we have done one example, find the polynomial function. This is degree 3, that zeros are 3, 2 plus square root of 5, 2 minus square root of 5. We have done similar. And this one also, we have a polynomial function of degree 1000. Let's divide this by x plus I. Find the remainder. All right. Find the product of the values of k, so there is a k here. When you divide this polynomial x cubed minus 3x squared minus 4x plus 14, divide by x minus k and the remainder is 2. We need to find the product of the k's, 1k, 2k's, 3k's, 4k's, whatever you get k's, multiply all of them together. As usual, I put here all the answers. There are 7 questions. The final answer here, see like the last one, find the product. The product is minus 12, but I did not tell you how many k's we have. Now, please, for complete solutions of these questions, you can see the video, all the exams questions, dividing polynomials, lecture 36 of the algebra course. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you that this is lecture 36 of the algebra course lectures. I wish I can see you in another video with another topic. Thank you very much for listening. Bye.